Okay, this is Calculus 2 on April 30th. We are in the pandemic as we have been for it seems like months and months and months. And a student has asked me about the integral 1 over x to the p dx. Now, hopefully, we all realize that this is, well, it depends on what it is, right? This is the integral of x to the minus p dx, which generally becomes x to the minus p plus 1 over minus p plus 1 plus c if um, if p is not equal to 1 and it equals the natural log of x plus c if p does equal 1. So that's how this integrates. Oh, but we were asking specifically about the integral from 1 to infinity of 1 over x to the p dx. Now, okay, so it depends on what p is. If p is 1, then this is equal to the natural log of x from 1 to infinity, which we approach with a limit. So it's going to be the limit as t goes to infinity of the natural log of t minus the natural log of 1. And hopefully you all have this little mental picture as to what the natural logarithm looks like. Y equals ln of x. And as we go to infinity, as t goes to infinity, this also goes to infinity. So this goes to infinity minus 0. It's infinity, so we say it diverges. It doesn't work. If p is 1. Let's do some other examples. Let's say it was, okay, and then the other one is going to be x to the negative p plus 1 over negative p plus 1. So otherwise, this equals x to the negative p plus 1 over negative p plus 1 evaluated from 1 to infinity. Or the limit as t goes to infinity of t to the negative p plus 1 over negative p plus 1 minus 1 to the negative p plus 1 over negative p plus 1. I don't know why I'm not calling that 1 minus p. I like to. Okay, now here's the question. Here's the question. If this really is, t to, if this is really is in the numerator, if this is the numerator, I don't know if you can ever see this. If this is in the numerator, then as t goes to infinity, the whole thing goes to infinity. And when does that happen? The t to the minus p plus 1 is in the numerator if that exponent is a positive exponent. If negative p plus 1 is greater than 0. Well, greater than or equal to 0, but if equal to 0 would be p is negative 1, and we just talked about p is 1. P is 1. So let's add p to both sides, and we say this is p is less than 1. If p is less than 1, then that is in the numerator, and this goes to infinity. But it's in the denominator if p, so we've talked about p is less than 1, we've talked about p equals 1. The real question is, what about p greater than 1? If p is greater than 1, maybe it helps to look at an example. If p is greater than 1, we're talking about something like the integral from 1 to p of 1 over x to the 4th power, or something like that. And what happens? Well, this is, the limit as t goes to infinity of the integral from 1 to t 1 over x to the 4 is x to the negative 4 dx. This is the limit as t goes to infinity, x to the negative 3 over negative 3. This is what I mean by it's not really in the denominator, right? It's not really in the numerator. We have the limit as t goes to infinity of t to the negative 3 over negative 3 minus 1 to the negative 3 over negative 3. This is exactly this thing that I had over here, just done more specifically. Instead of with p's, it's with p is negative 4. P is 4. P is 4, and so it's negative 4 plus 1. Right. But what happens? What I'm saying is, it's not really in the denominator, because t to the negative 3, this is the limit as t goes to infinity of, let's see, negative 1/3. That's 1 over t cubed. The negatives cancel out. The 1 to the negative 3 plus 1/3. Now, as t goes to infinity, t to the negative, t cubed goes to infinity. 1 over something goes to infinity, goes to 0. And so the whole thing is 1/3. And so the end result is that the integral from 1 to infinity of 1 over x to the p dx equals, let's see, it diverges. That is to say, it goes to infinity, it doesn't have a limit, if p is equal to 1 or p is less than 1. So less than or equal to 1. And it converges, we do have a limit, if p is greater than 1. And we can even figure out what it's going to be if p is greater than or equal to 1, then the negative p plus 1 is a negative exponent. It comes down here. This whole thing goes to 0. And then we have just this, and the negative, this is just 1 over negative, it can distribute the negative down here, positive p, negative 1, so it becomes p minus 1. It converges to 1 over p minus 1. So examples of that would be the integral from 1 to infinity of 1 over x to the 7th dx. P is 7, which is greater than 1. It converges to 1 over 7 minus 1, 1/6. The integral from 1 to infinity, 1 over the cube root of x dx. P is 1/3. That's less than or equal to 1. It diverges. If you took the integral of that, that's the x to the negative 1/3. It will come up to the numerator, and then as the t part goes to infinity, that numerator, that thing going to infinity in the numerator makes the whole thing go crazy big. So hopefully you get that. This is the general formula, and this is going to be used so much in Calculus 3 because we will compare things to this integral. So hopefully that makes sense.